Hey guys, and welcome into my room, and welcome to this statistics session. Today we're going to go over Lab 1, which is the bone cement lab. I have all the data from a previous semester, and it's been modulated a little bit. It's going to be different data set than you guys are going to have, so your means aren't going to exactly line up. Don't take that as a discouraging factor. Um, you guys should be fine with your data. You should be getting it in a similar fashion that I have in this Young's modulus table. Should already be transferred to um, Young's modulus for you. The important thing now is to run our statistical test and then put it onto graphs and figures that you guys can use during your abstracts. So the first step is to decide if you're going to do this in Excel or GraphPad Prism. Now, when I was first taking the class and I did Lab 1, I did it in Excel, but it was a lot harder than it needed to be. Doing ANOVAs in Excel is not fun. I've done it. It's not my favorite thing. It's a lot harder to interpret, but if you do it all in GraphPad, I'll show you how easy it is. It is such a time saver and such a life changer, honestly. I really love the program, and luckily you can get a free 30-day trial. Um, but let's talk about GraphPad Prism, I guess. GraphPad Prism is a really high-powered uh, data manipulation software. I imagine you guys have already been introduced to it. I'm not exactly sure what kind of presentations you guys have been watching up to this point. Um, but basically, it makes excellent figures, and it'll make your abstract look really professional, and it's does all the work for you pretty much. Um, but I guess my recommendation is, if you haven't heard this already, one person get the free trial for GraphPad Prism. They're designated as the statistics person for the next month. Um, you can only get one free trial. It's linked to both your email and your computer ID, so it makes it really difficult. Actually, I can't even do it on this computer. I have to remote desktop to my other computer so that I can even use GraphPad Prism with you guys, um, because it wouldn't let me get it on this computer again. And it's really expensive. It's a really expensive program. So with that said, let's just jump right in. Let's look at our data set here. So I just copy pasted the data onto this sheet, but what I did was I only pasted the values. So now it should be a lot less, um, like there shouldn't be any kind of weird formatting, anything like that. Uh, so I created this table. We'll come back to this and I'll explain why I did this, why I kind of created it this way, where I copy pasted all of our different things from head to tail. But first, let's get into GraphPad Prism and let's get setting up kind of our initial data and figuring that kind of stuff out. I'll give you guys a little mini tour just in case you haven't seen it before. And let's jump right in. So when you open GraphPad Prism, you're going to see this page. It's going to have a new table graph option. And essentially, the table graph is going to be dependent on what kind of data you're trying to do, what kind of statistical test you're trying to perform. Now, if you're trying to do just simple things between like multiple y data sets on an x-axis, say like time, your XY table is going to be great. You're probably going to use it later on in the semester. Um, Column is great for t-tests and one-way ANOVAs. That's the table that we're going to be using today. There are also a lot of others like grouped, which is great for two-way ANOVAs. And again, it helps you out with all these different things for you. But let's just start with the column graph. We're going to go and enter or import data into a new table. This it'll automatically tell you like, oh hey, you can do a tutorial. I don't think you need a tutorial. I mean, you can definitely play with it on your own time if you'd like, but I'm gonna pretty much teach you how to run it. So enter, import data, enter replicate values. We're just gonna do that stacked into columns for this, and that's why we pasted them head to tail, because we're just going to be measuring the difference between the different amounts of plaster in each one. And I'll explain that. I'll explain why in a couple of minutes. But first, let's create our table. All right, so we get this wonderful table pasted in here. GraphPad Prism is wonderful because you can copy paste directly from Excel, and I'll show you exactly how high powered this is and how easy it is. So we're going to go in here. I'm going to take my data table with all of my data in it, including the titles. I'm just going to hit Control C, and then I'm going to go back over, click on the title, and just paste. It pastes the titles in, it names your groups for you, and then it pastes all your data in. Nice and easy for you. And as you can see, 180 replicates for all three groups. And then we are ready to start doing our statistical analysis now that we have our data in here. And let me tell you, when you're pasting in from Excel, it's super easy. It's easier to format, I think, in Excel, just because like copy pasting and moving things around, resizing the cells. I'm just more used to it in Excel myself. But this is a really high-powered spreadsheet editor in here, and the different graph types really makes it, data table types really makes it useful. So I guess the first thing we're going to do is we're going to discuss the one-way ANOVA versus the two-way ANOVA distinction and why we're running a one-way ANOVA on this data. Well, I guess my first thing is I would invite you to run the two-way ANOVA if you'd like. I'm not really going to go over that in this. If you're interested, I will talk about it more in an email, or maybe I'll post another video talking about it. But basically, I ran a two-way ANOVA on these data sets earlier, and for this specific data set, there wasn't an interaction between the weight groups. Now, I guess a two-way ANOVA, you're going to be comparing two different variable interactions, two different independent variables that you're changing, which in this case would be when you place the weight and it's 500 grams versus 700 versus 900. That'd be your first independent variable. And your second independent variable is your chemical composition, how much plaster content you have in each PMMA sample. But I looked at it, and when I ran the two-way ANOVA, it said there was no statistical significance between or it wasn't significant in that data set. It might be significant in your data set. Actually, I invite you to look at that. And that's the great thing about the statistics section here, is that it's very much like you do what you want. You run the statistical test that you want. You just have to justify it, right? You have to justify why you ran a two-way ANOVA and why you said, hey, I want to run a two-way ANOVA, include this in my abstract. And you can say, hey, actually, it was statistically significant, and I felt it was important to mention in the abstract. And then you'll get points the same as someone else who justified their statistical test. So for this one, we're going to do a one-way ANOVA. And up here is where all your tools are going to be. Now, in order to run any statistical test, you're just going to click on Analyze. It's going to bring up this table. Now you can look it up all these different things. Since we're using columns, a column graph, we're going to look at this column analysis tab. It already knows I want to do a one-way ANOVA. I'm going to click on the one-way ANOVA, click OK. Now, here is some interesting settings. This, like again, has a lot of versatility. It'll let you do anything you want. It gives you nice graphics on the different things. Right now, we're going to click No Matching or Pairing. Yes, use ANOVA for the Gaussian distribution assumption, and then also assume equals SDs. We're going to go to repeated measures. There's not going to be anything for just regular. Next, we're going to go to our multiple comparisons table. Now, this is all about the follow-up tests, and that's like your two-key post-hoc test, your Bonferroni post-hoc tests. So I would compare the mean of each column with the mean of every other column. That's what we're going to do in this. In your options, we're going to go through here. You can do Tukey, you can do Bonferroni. Those are the ones that we learn most about. There are a bunch of these other ones. I'm not exactly sure how those correct for. I'm going to use Tukey for this. You can use Bonferroni. We'll see what happens. Report the multiplicity value. Keep that checked. Residuals, just leave it. This is going to give you some graphs that you don't need for this experiment, or at least for your abstract, unless if you can find something, some reason to post them, but you don't need them. And it just calculates it for you. Now, some interesting things to note. It's going to have a summary here. Your p-value. We're trying to test for a p-value of less than 0.05 or 95% confidence interval. This p-value is less than 0.0001, which means that it's statistically significant. Now, GraphPad has this wonderful feature where it has asterisks, and that denotes how significant your data set is. 4 asterisks is extremely significant. That's the most significant you can get. Then there's 3 and 2 and 1. We can go over here in this is our results tab. we can go over here to our multiple comparisons, and we can look at all these different things. And now here's where you're going to be looking at is it significant? Is it not significant? This tells you if it's below the threshold for significance. NS means not significant. 4, extremely significant. 3, very significant. Not a little bit less than 4. You can see the adjusted p-value is, still extremely low for what we're looking for, which is good. Now what we're going to do is we click on the graphs. It already has generated a graph for us. All we have to do is choose our different things so we can plot our individual values, which if you do it this way, it's going to be insane because we have 180 tests here. There's a lot of different options you can do. For this, I normally do this here, this regular bar graph with error bars. You need to have error bars on your graphs. I always use the standard error model, SEM, for my bars. Standard deviation, it usually ends up being too big. It kind of doesn't really show the significance as well, and honestly, it bumps down your mean a lot because a lot of times there's a pretty decent amount of variance. So I usually use SEM or 95% confidence interval, but again, this is something that you need to justify. You just click OK. Now it's generated the graph for you, and all you have to do is just click on whatever you want to edit. So give your graph a descriptive title. Give your graph a descriptive title. For your axes, put in your value and units. Make sure you have units in parentheses on all your axes. You can put in something there. And it generates just this really, really nice graph. Now, the next most important thing is how do you edit this graph? How do you make it different, everything like that? You can change the type here. Everything you're going to need pretty much is going to be in this change piece here, or this draw piece here, or right. So like we can go format axes, we can change the ticks, we can make the x-axis, like we can shift the x-axis so that it's not like auto-scaled like this. We can change the scaling. Same with the different axes, we can add a different axis. We're not going to change anything because this is actually a great graph. We're going to go into a format graph here, and we can change the fill, we can look at colors, we can change the plot here, we can change the style, we can adjust which data set we want, we can show all these different settings. Again, I encourage you to mess with this stuff, see what you think, see what it looks like. But right now we're just going to leave it how it is because it looks good as it is. Now, if you want to add automatic pairwise comparisons, which is what it calculated here in the test here, you can just click on this, and it automatically adds it, and it compares them too. So now you can say, oh, that one's not significant, that one's 3 stars asterisk, that one's 4 asterisks. This one's the most significant. Personally, and for the use of this class, I think that this method is a little bit more distracting. Normally in this class we like to do either bars or symbols, and this kind of has both. While doing the significance, again, you can include this, talk about it in your caption if you would like. Personally, I think that it doesn't look as good. I mean, it looks nice, but it adds a lot, especially when you start getting like things with a lot more comparisons. Like if you have 5 pieces or even 4 pieces, you end up getting like a lot of lines, a lot of asterisks floating around. For this, what I would do is you can go in here and you can actually draw your own lines. So you can draw your own piece like this, and just put that in if you want, and you can do this, or you can put like a hashtag over it for different symbols, or just leave it blank. If I was doing it this way, I would leave it blank myself. But really what I would do is I would do lines like this, draw across, and then that would be all you put, and then that just shows like those are significant. You have to list that in your caption. Again, everything you do is significance, you have to list in the caption. My personal favorite thing to do is just to put in text. And what I'll do here is I'll just say, okay, what did we find? We found that this PMMA plus 0.4 grams of plaster was statistically significant to the PMMA only sample. I say that's an asterisk. And again, you can define this how you want. all definitions go in the caption. Don't put it in a legend on the graph, put it in the caption. So we found that that was significant with the PMMA only sample, and we also found that the 0.4 gram plaster and the 0.1 gram plaster are statistically significant. So I'd say let's use a dollar sign for that. Now, what I can do is I can move this around, line it up, make sure that it lines up with the center here. And then in my caption, I would put the asterisk means that sample is statistically significant compared to the PMMA only sample, and the dollar sign means that it's statistically significant compared to the 0.1 gram plaster sample. This is important. Don't put the asterisk over both the PMMA only and the PMMA 0.4 gram plaster. Don't put it over both. It's just crowded. It's unnecessary, especially if you're going to say that the asterisk means that it's statistically significant to the PMMA only. And again, this gets more complicated as you start getting like more and more items that you're comparing. Instead of just 3 sets, you have like maybe 5 or 6 or 7. Once you start getting into those, you just want to put an asterisk over the ones and then explain, hey, those are significant to the first one. And then it will clean up your graphs. It'll make them look a lot nicer. But this right here just sums up pretty much what we're going with, right? Because then this is statistically significant with this one's statistically significant with this, but these two aren't significant. And since we didn't put an asterisk over it, we don't have to explain anything here. For the title, again, make sure it's descriptive. Don't just say plaster content versus Young's modulus. That's not descriptive enough. It's just a plain title, and you'll get marked off in your figures on your abstract. Discuss what the graph shows, what kind of conclusions can be drawn from the graph, what kind of things can be learned from the figure, something useful for the reader. All right, and I think that's pretty much everything I need to go over for this lab for data manipulation. This lab's pretty easy. And again, GraphPad Prism, it's like a learning curve, but once you get past like, the initial like how to run an analysis, how to run a one-way ANOVA, how to run a two-way ANOVA, you really start taking off in what you can do. And the statistics side actually was my favorite part of the semester, was doing the lab statistics. Now I think we're good. That's everything I needed to cover, I think. So then let's close out. We had our data all in our data table. We ran our analysis, and we looked at our comparison chart. And on our graph, it automatically put it in for us, but I changed it personally because I think it looks a lot cleaner, a lot neater if we just do this. And always discuss in the caption. Again, your data is probably going to look a little bit different than mine because mine's from a different semester. But if you have any questions, feel free to reach out. Any questions about GraphPad, any questions about this lab, please feel free to reach out to me. You can find me on the People tab, or you can reach out any other way that you can find me. I'm willing to help you with this kind of stuff. And I hope that you guys have a good time running the statistics and that your abstracts turn out great.